Hello everybody, in this video we are going to solve another problem on LeetCode Live. Today we are going to pick a problem of easy difficulty. So far we have already solved the two sum problem. If you haven't checked out my video on that problem, please go to my channel and check it out. The next one is palindrome number. Okay, let's read the problem and make sure we understand it. Given an integer x, return true if x is a palindrome and false otherwise. Okay, that's pretty straightforward. Basically, that's a number palindrome like a string. So 121, if we use reverse digits, is also 121. So it's a palindrome. Negative 121. So looks like negative numbers are not considered palindrome. Their explanation is that so they're basically using the string explanation. If we reverse it, it's like 121 minus, and it's not a palindrome. Similarly, x equal to 10 is not a palindrome. That's straightforward. Okay, the constraints are that the value of x is basically it's the full signed 32-bit integer range. And that makes sense. Could you solve it without converting the integer to a string? Yeah, I mean, as soon as I read the problem, I thought, it's completely fine to do it, just with integers, like peeling off the last digit by doing the modulo operation and appending that to another integer and continuing that, and then dividing x by 10, then continuing that, right? Like typically how we do like an int to string or string to int or something like that. And that would work. And the only thing to think about is basically the full range, right? Given that x can be input given to us can be like the extreme values of the signed integer, what happens with that if we do that? And we'll think about that in a minute, but let's at least write down the algorithm here, although it is obvious. But let's take a little bit of a bigger example, an example with more digits, I mean. So let's say our number was 1, 2, 3, 4, 3, 2, 1, right? So this is x. So our idea is that we will, start another number. Let's say y. Initially it will be 0. Actually, let me write it down here because I'm going to change both of them. And then, y equal to 0. And then the operation we'll do, like I said, is the x percentage 10. That gives us the digit. Sorry about that. X percentage 10 gives us the digit. So let's say d is equal to x percentage 10. And then x equal to x divide by 10. And then y equal to y times 10 plus d, right? And we continue doing that until there are more digits in x, which is basically I should write it fully while x is greater than 0, right? Just writing in pseudocode, basically we do this, right? And if we do that basically, and if we write down what happens step by step, initially 1 2 3 4 3 2 1 and y is 0, but next will be 1 2 3 4 3 2 because we took a remainder by dividing by 10, which is 1, and then we divided it by 10. So that's that, and the y will be 1. And then x will be equal to 1, 2, 3, 4, 3, and y equal to 1, 2, and so on and so forth. And finally, x will be 0, and y will be equal to 1, 2, 3, 4, 3, 2, 1. And then, of course, we'll save the original x in some value. And then finally, here we return if original x equal y, right? So that's the algorithm. I mean, I could have also written the code, but by habit, it's always good to kind of write down what we are doing. Now, before we write down the code, I want to think about the extreme values of integers. So, it's roughly 2.14 something billion a max value, but I don't know the exact value. And in this case, we do need exact value to kind of. Okay, so these are the values, right? So let's pick that. I mean, negatives don't matter because we will short circuit negatives and say they are not palindrome. So let's take this value and then see what happens. So if x is this actually this one y could go out of range, right? Like The reverse is like 7 billion something, 7.463 something billion, right? And y could go out of range. So is that an issue? I mean, like actually, funnily enough, it's not an issue, and the reason is because what happens is that when let's say we take this number in general in Java, not just for this problem, right? We take this number and we add 1 to it, it will actually wrap around to the maximum negative number, right? So it will pretty much wrap around, yeah, it will wrap around to this number here, right here. And so that is why what will happen is even though y will overflow and wrap around, uh, y will have a value which will automatically tell us x is not a palindrome, right? So it's okay for y to overflow and kind of go there. It's not going to generate an exception if I remember correctly. And there's a very common thing in most languages which use like the two's complement way of encoding integers. If you don't know what I said there, don't worry about it. I think what all you need to think about is it wraps around, right? If you have maximum positive value and you add one, it wraps around. If you have the minimum negative value and you subtract one, it wraps around also. Okay, so I think it will be fine. We don't have to worry about it. Okay, so let's try to implement this approach. We'll try to implement it here. We are only taking one approach. So, okay, so we say, like I said, we have to save the original value of x. So let's do that. And then we have to do, I'm not going to call it y. Y was just to explain the algorithm. Let's say reverse of x. In fact, in Java, we can make such a variable final, right? And that's the reason is because we are never going to change the value of origin x after we assign it the initial value. And that means it's the final value what it has. And it's good to do this in Java because that way, even if we accidentally try to change the value, Java will actually throw a compiler error. So that will be nice. Okay, so here we just say while x is greater than 0. This is going to be pretty straightforward. We pretty much do what we did there. Is an int digit equal to x percentage 10, and then we say rev x equal to rev x times 10 plus digit, and then we say x equal to x divided by 10, right? And we continue this while x is greater than 0. And then last we say return if original x is same as rev x, right? Let me make sure I did everything we needed to do. We needed to do division to digit, found that, we divided it, and then we added the digit there. Yes, we did that, and we did that. Okay, great. I think this should work. I mean, there is always a possibility of compile errors when we write so much code without an autocomplete ID, but it looks like no. Okay, great. We definitely want to add the test case that we thought about, which is like the maximum value. This one here, 1 sec, and make sure that returns false. And in fact, I think what is another thing is we should also add a test case where there is a palindromic as big a value as possible. Okay, I don't know why this is taking too long. Maybe the special value made it spin. Okay, that's interesting. Wow. Okay, let me try again. I don't know what happened there. Whoa. It is stuck. Let me refresh the page. How did I make it stuck? I think it saves my work. Okay, don't tell me it didn't save my work. Okay, it did save my code. Okay, great. Let's try again. I'm very curious what happened there. I mean, is it a infinite while loop if we do that? Is that the bug? Let's try again. No, it is not. Okay, something funky happened there. I have no idea what happened there. Okay, great. So that worked. And the other test case that I was thinking of adding is basically the maximum, okay, how many, maximum possible palindromic number, right? So 21474. So I think we can do 47412 here, right? And this should return true. And this is, if you think about it, the biggest number which will be a palindrome. Anything more than that, it will not be a palindrome. Yeah, okay, that's cool. It worked out. Okay, great. Hopefully that made sense. Pretty straightforward approach. I mean, every time we have problems where the extreme values of a certain numeric data type could cause issues, it's always good to think about whether they need special handling. In this case, we were very lucky, and it turned out that the wrapping around actually is a completely fine behavior, and we will actually get the answer we need. So yeah, we can try to submit this and just see the performance of our code versus all the other submissions. Cool. Okay, yeah, we are beating about 72% folks. I mean, a lot of people will have this implementation, so that I'm not surprised by. And memory is like not reliable, like we are not using much or any extra memory so often. Okay, great. Hopefully that was helpful. If you're liking what I'm doing on this channel, please subscribe to my channel and consider hitting a thumbs up on this video. See you guys next.